I'm going to go over how to complete several density problems using examples, and one of those I'm going to be using the density triangle to help us. So the first example I'm going to go over is problem number 5 in this particular problem set. So the first thing we need to think about is what they're actually getting us to solve for. It says pure gold has a density of 19.32 grams per milliliter. All right, so that's going to be pretty important as we solve the problem. It's giving us density. What would be the volume? All right, now that was a question. What would be the volume? So that is our question that we are being asked, is to solve for volume of a piece of gold. What would be the volume of a piece of gold if, I think this is a typo, sorry, if it had a mass of 318.97 grams. All right, so they're giving us a mass also. So they're asking us for volume. We need to be able to figure out how to use the density equation to do so. That's kind of hard when you solve for volume. One of the easiest ways to do this would be to use the density triangle. So to use the density triangle, what you do is you take your hand and you cover up what you're solving for. Instead of my hand, I have a gigantic black circle. All right, so I'm covering up volume. Notice that after I cover up volume, what do I have left? I have m over d, or in other words, mass divided by density. So when I go back to my equation, what I'm going to write down is that volume is equal to mass over or divided by density. So I'll plug in the values from the problem that I'm given. So mass is going to be 318.97 grams, and the density is going to be 19.32 grams per milliliter. Now notice how I wrote it in this fraction form as opposed to a linear form as you would if you were typing it. The reason I like to write it like this is I want you to notice what happens to your units when we go to cancel them out. So when you have division, the grams in the top is going to cancel with the grams in the bottom, and then you have the unit milliliters left. So that's convenient because if I'm solving for volume, volume should come out in milliliters. So I want you to grab your calculator. I'm going to grab mine. We're going to do 318.97 divided by 19.32. For the purposes of this experiment, or this problem, we're just going to round to 2 decimal places. We're going to have 16.5, and if I round to 2 places, I get 1 milliliters. So notice how in this problem we use the density triangle to help us out. All right, the other problem that I wanted to go over with you is number 7. So let's take a look at number 7 and see what we're asked to solve for in that problem. It says, how many grams of tin would occupy 5.48 milliliters? All right, so they're giving us volume in this particular example if it has a density of 7.265 grams per milliliter. All right, so we're asked to solve for grams. When you look at the density equation, density equals mass over volume, we know that grams is a unit of measurement of mass. You could go ahead and solve for mass by plugging things directly into this density equation, which if you can, that is phenomenal. I'm going to show you what you can do if you're uncomfortable setting up the density equation. So I'm going to move my little density triangle down here a little bit, and I'm going to move my black circle down here as well. All right, so if we were going to use the density triangle to help us, what we do is we take our hand and we cover up what we're asked to solve for. We're asked to solve for mass. So I'm going to take my black circle and cover up the mass, and notice that what is left is I have D times V. So when you cover up mass, you're left with D times V. So that means that mass is going to be equal to density times volume. Now that kind of takes care of the algebra issues for me if I have problems rearranging this equation. So I'm going to go ahead and plug in the density, which is 7.265, and that was grams per milliliter. Again, notice how I'm writing it like a fraction. And I'm going to multiply that by the volume, which was 5.48 milliliters. Okay, now what I'm going to do is I'm going to get my units to cancel out. And again, the reason that I write my units for density like a fraction is because I can easily see how they'll cancel out. I have milliliters in the top, which will cancel with milliliters in the bottom. And now I'm going to grab my calculator and do this multiplication. So grab your calculator. We're going to do 7.265 times 5.48 equals, now we're going to have 39 point, I'm going to round to 2 decimal places for the purposes of this exercise, and I'm going to have the unit be grams because grams is the only unit that didn't cancel out, and that makes sense since I was solving for mass, and mass is measured in grams. All right, let's take a look at the other problem that I wanted to do with you, which is number 8. So for number 8, this time we're again asked to solve for, or let's look, the density of silver is 10.49 grams per milliliter. If a sample of pure silver displaces water in a graduated cylinder from 32.9 milliliters to 53.7 milliliters, what would be the mass? All right, so this time they're asking us to solve for mass yet again. But the one difference in this problem is that they're giving us displacement. They're telling us that a graduated cylinder is going to change its volume. So one of the things we need to think about when we talk about displacement is we have to think about a graduated cylinder. And I am terrible at art, so this is supposed to be a graduated cylinder. So we're going to think about how this graduated cylinder's water volume is going to start at 32.9 milliliters. I'm going to add an object, and when I add that object, here it is, it's going to cause the water volume to increase. And when the water volume increases to its new level, which they told us is 53.7 milliliters, I'm going to need to plug in the volume of this object into the equation. But what is the volume of the object? Is it the 32.9? Is it the 53.7? It's actually neither of those. It's the difference between them. So what we're going to need to do is we're going to need to subtract to find the displacement, or how much water was moved because of the object's volume. So to do that, you're going to take your calculator or your head, and you're going to do 53.7 milliliters subtract or minus 32.9 milliliters. So let's do that real quick in our calculator or your head, and you're going to get 20.8 milliliters. So we're going to assume that the volume of the object is going to be 20.8 milliliters based on the amount of water it displaced in the graduated cylinder. So now they asked us to solve for mass. So once again, you can look at the density triangle and notice how if I take my hand and I cover up mass, notice how I'm left with D times V. So I'm going to solve my problem using that equation. So mass is going to equal density times volume. Now they already gave me the density of silver. It's 10.49 grams per milliliter. And they gave me the volume by displacement, and I already found that to be 20.8 milliliters. So let's plug in the 20.8 milliliters. And if I take a look at those units, so the units of milliliters are going to cancel from the top and bottom. I'm going to be left with grams, and that makes sense since I'm solving for mass. So grab your calculator. We're going to do 10.49 times the 20.8, and you're going to get a rather large answer. You're going to get 218 for this activity. We're going to round to 2 decimal places. 218.19 grams. So you can see how displacement helps us. You can also, and review, remember that the density triangle, all you need to do is you need to move your hand to cover up what you're solving for. That also works with density. I can use my hand to cover up density, and notice how I'm left with M over V, which we already knew. Density equals mass divided by volume. So there's a couple ways you can use the density triangle. You just move your hand over top of whatever you're solving for. All right.